I would like to begin by acknowledging that our speakers and myself are gathered here today on the traditional, ancestral, and unceded territory of the Musqueam, Squamish, Tsleil-Waututh people. Onto our agenda today. In a moment, I will give some tips on how to participate in our Q&A platform. I'll make introductions, give a brief program overview, and I will hand over to the three professors here with us today who will speak about the program curriculum and career considerations before they answer your questions. Closing with some important information about fees, dates, and how to register. Now on to tips. For user experience, we have muted your audio and video. Chat feature is turned off. Open a new tab in your browser or second device and type slido.com and enter event code UBCSD. For anyone unable to join us today or needs to leave early, we are recording the session. We plan to post the recording on UBC Extended Learning YouTube within a few days of the session. My name is Emily Wu, Program Leader at Extended Learning. And joining me today is Professor Gregor Kiczales. Gregor is a professor with UBC Computer Science since 2000. At UBC, he co-founded the Software Practices Lab with Professor Gail Murphy. He designed the Introduction to Software Development course and its online version. He's a fellow of Association of Computer Computing Machinery, known for his Association for Computer Machinery, known for his work on the aspect-oriented programming and reflection in programming languages. Next, we also have Professor Elisa Baniassad. Sorry, Elisa, do you want to chime in with your last name here?
Sure, it's Baniassad.
Baniassad, an associate professor of teaching in the computer science department at UBC. Elisa teaches UBC's undergraduate software construction and software engineering courses. She developed a software construction MOOC that is part of the UBCX Software Development MicroMasters. She has received numerous departmental teaching awards over the years. And last but not least, joining us today is Professor Reid Holmes, an associate professor from the UBC Computer Science. He teaches advanced software engineering courses focused on software design and architecture. His main research focus is to better understand how developers think about complex problems and finding new ways to alleviate difficulties they have with these tasks. I would encourage you to visit our website for a full biography of our presenters today. Before we move on to the program overview, I'd like to launch an anonymous poll on Slido platform. So the question for you is, what comes to mind when you hear software development? So please open a browser, slido.com, and type in the event code UBCSD, and then type in your questions. Type in the answer to the question, what comes to mind when you hear software development? So we have make a better world, coding, programming logic, vaccine booking systems, the future.
That one's certainly apropos.
Very cool. Thank you for these contributions. We have 13 responses so far. Designing computer software to solve problems or provide services. Great. We have a second question for you. What industry are you working in? Please share us a little bit about yourself. Education, finance, insurance. A lot of educators here. Transportation engineering, structural engineering. The diverse, diverse participants we have here. Great, thank you. Now, on to a very brief program overview. So the software development program we're offering is 100% online with 6 sequential courses. They're expect to spend about 10 to 14 hours minimum per week on the course and about 60 hours per course. We have weekly virtual office hours scheduled with your UBC instructors, and we'll publish those office hours on the website. There are regular discussion activities to support your learning, as well as practice problems and assignments to track your progress. Now I would like to pass to Gregor, Elisa, and Reid to speak about the curriculum.
I think Elisa's going to do this first slide that kind of paints an overview of the whole sequence.
Okay, hi everyone. Oh, second. Okay. Yeah, so there are various things that you learn throughout this program. I think the way that the program is basically arranged is that you kind of look at, is there a second slide that goes over the program shape? Emily, is there like a second one? Okay, no, that's okay. We'll just, I'll talk. Yeah, this one. Okay, great. So the way that the program kind of shapes is that you're looking at different sort of levels of all of these different concepts throughout the sequence of courses. So basically, by the end of all of these, you have an understanding of these 6 things. So you have a kind of idea of how to manage a product life cycle. So this is this idea that you're able to integrate. Just not knowing necessarily what everybody knows about software. The idea with software is that you are building an application up, right? And so you're trying to build something, and gradually as you're building this thing, it might change. New requirements might come in, and you might realize as you're building it that there are new that there are basically changes that you have to make to your system as you're building it. So you need to know how to build something to begin with, and you need to know how to change that thing as you're building it up. So it's kind of almost almost like 2 different activities. You have to learn how to begin a project, and then you have to know how to grow the project. And growing the project takes a lot of kind of insight and a depth in practice as well. So in the first course, in fact, all of the courses, you kind of learn all of these things. And so these learning outcomes that we see here, managing product life cycles, translating client needs, these relate to either more or less to beginning a project and sort of setting up the initial infrastructure for that project, beginning its inception, and then into the migration, into growing that project so that it can encompass all of the needs of your clients. So actually it kind of begins at the green one, which is translating the needs of your client into design. So in the very beginning of a project, you think, what should this thing be? And so you kind of begin there, and you talk to your client. Maybe that client is you, maybe you're developing something for yourself. And so you think, what should this application be? And so you do something which is called eliciting requirements, which means just gathering requirements, deconstructing them, trying to figure out exactly what they mean. Like, if you were trying to build an application like Twitter, what would you want it to do? You want people to be able to post tweets and see tweets. So you're thinking about all of these kinds of requirements, and this is what requirements means. It's just things people want to be able to do with your system. And then, of course, as any application grows, I'm sure all of you have noticed that applications, when you first download an app on your phone, it's kind of version 1, and then it's like, hey, we have an update. Every application now seems like it goes through this kind of update system. So these updates are this maintaining living code bases where you might be adding new functionality to an existing system. You've already built the first version that gets at your basic set of requirements, and now you kind of want to grow that system. So you've once again gone back to your clients, you've realized that your system needs to grow to some extent, and you say, okay, now I want to add in another set of things. And so as you're kind of doing all of this, what you're doing is you're managing product life cycles, which means that you are trying to figure out how you can test that what you're doing is robust. You're trying to make sure that what you're doing is going to continue to be growable. You want to be able to work in your team, and also you don't ever want to break something that your clients are using. So this is assuring system quality. So all of these things are different kind of practices that we teach in the program. Gregor and Reid, do you have anything else to add about this?
Yeah, I mean, I think it's just important to recognize just how interactive the field of software development really is. I think you captured it really well, that there's a lot of constraints that are involved in building real systems, and it's all about working with different stakeholders, customers and technical teams, and working together to build systems that solve real world problems. And I think it's often underappreciated just how much of a team effort any non-trivial software system is. And I think you captured that well in your description. Is there anything you wanted to say, Gregor?
Yeah, I'll just, I think everything you've heard so far from Elisa and Reid is clearly bang on. I just want to highlight one thing that Elisa said, which is that for those of you who maybe have never programmed before at all, most of you, this might look like a lot. And I just want to highlight what Elisa said about how we learn it. You know, when you're first writing the simplest little 5 lines of code, then translating client needs into design is complicated. And so we basically do all of this stuff starting with very short programs, and then longer programs, and then longer programs, and programs that have more different parties involved, and programs that last for longer. So you really will be learning these things from the beginning, but on simpler problems. And then that will grow as you go forward. So don't worry if this seems like too much to start with on day one. We make it start on day one by starting on smaller problems. But then the foundation is really there for you for going to larger and larger and larger problems. Should we go on?
Yeah, so one thing you'll notice when you take a look at this description of what a software engineering, like a job description looks like, is you'll see a really tight mapping back between this description and the kinds of topics that Elisa was talking about in the last slide. Researching, designing, evaluating, integrating, and maintaining software are all parts of the software development lifecycle. No matter what system you work on, these are all challenges that engineers need to solve. And while in the past, these used to be much more specialized roles, you would have someone who was just a designer, and you have other people who only did deployment. The field has evolved such that all engineers really need to have a handle on these different aspects of the software development process. And that's reflected in this slide, really just in the diversity of different aspects of the job that a software engineer undertakes on a given day. Could we go to that next slide, Emily? So one thing that shouldn't be surprising to any of us is just that the need for software engineers continues to grow. I'm sure that certain contractors in the province wish they had a few more engineers right now so they could have their vaccine booking system ready for us last week, and hopefully we'll see something from them soon. But there's just always new places where we expect software to be used where they weren't used in the past. We can think back 20 years ago to the tiny amount of software that was in cars before, and now it's said that the cost of the software in a modern car is 60% the cost of the vehicle. And when you think about it, a car is like a lot of metal and a lot of parts. And for the code itself to be worth more than half the cost of that car is kind of crazy. And our expectations for software continue to evolve. And that's really what's driving this employment trend in practice. Next slide. And obviously, these are well-paying jobs. Like I said before, they're super diverse, and we'll come back to that again on the next slide, but they also pay very well. And that's just reflective of the fact that there is a shortage, and the market has to compensate for this fact in order to encourage people to work, get people to work for their companies. Next slide. So this slide is a little bit interesting to me. I'll be honest, I was surprised that the computer system design and related services accounts for such a large block of the industry. I'd be honest that I would guess that this is an upper bound, if anything. Computer people, software engineers, are embedded in all kinds of industries. Most industries have some technical people on their team. And as we, as individuals, as humans, and as organizations, think of new ways that we want to improve different business processes, different things that we do in our lives, things that we do for fun, with code, with software, with systems, we end up pushing technical teams into more and more different organizations. So this is something that I would expect to diversify more than centralize going forward, where we see software engineers as members, as integral members of more traditional engineering teams, more traditional sales teams, more traditional service teams than we have ever seen before. So this is going to continue, the field's only going to continue to diversify over time. Next one, Emily. And when you think about the career considerations and the kinds of skills that we're talking about here, I mean, it's kind of interesting to go down this common skills slide: communication, problem solving, troubleshooting. The top three are really all about working with teams, and I can't stress that enough. A big part of working in a software development team is having the technical communication skills and the technical understanding to be able to interact with the domain experts. And for many of you, you are the domain expert. So this is really great, right? So what a common path for people who come into the field is to be a domain expert, to be on a team already and say, hey, I need some more technical skills so that I can be that person on my team. And this is something that is really, really great to see. And when we go through the top hard skills on the left, a lot of these are being handled directly in this program. We are dealing with software development. Elisa's courses are taught in Java. We'll talk about agile methodology and software engineering in my courses. We teach a variant of JavaScript, a superset of JavaScript called TypeScript in my course as well. So that gets handled. And then Gregor's courses at the beginning really, like he mentioned earlier, start at a really fundamental level to help bring you into this process, because there is a lot of material to learn, and we don't want to be overwhelming. I think with that, we'll hand it over to Gregor.
Oh, I thought this was you, but I can do it.
Perfect.
Oh, I think this was the one that I was referring to earlier. That was, sorry, I just didn't know where it was in the deck. Apologies about that. So this kind of gets, do you mind if I talk over this one, Gregor?
That's fine, because you wrote it.
Okay.
I not only mind, I prefer.
Okay,
Or don't mind, I prefer.
You can feel free to chime in. This basically looks at the way the program is shaped in terms of those more underlying learning outcomes that you get by the very end. So that longer list of items, like being able to build a robust system, being able to manage the maintainability of the system and grow the system, and all of these different things, eliciting requirements. Those are all the things, that sort of items that you learn. And I just wanted to get back to what Gregor had said also about the fact that, like, this does sound intimidating at the beginning, but it really is eased into. We sort of look at it, like Gregor said, in sort of a microcosm first. But all of those threads are there, thinking through a problem, imagining how you would convert it into programming. That's a kind of personal experience that you will then, by the end, have an understanding of how to do in terms of bigger requirements that are handed to you more from like a client. And so what this basically gets at in terms of the program itself are more like these three things. So you'll be able to walk away with an ability to look at mechanisms for reasoning about design, building and evolving software systems. So that is a thread that runs throughout all of the courses. You'll have been working with these modern tools and environments. So starting with the first course, working with a functional programming methodology, which is increasingly pervasive in industry. And then finally working on a very modern full stack development in Reid's class. And then finally, but the biggest thing that that we all kind of want to put forward is that the thing with software development is that it's never the end. It's never settled as a field, because software engineers, one of the things that we like to do is make our own lives easier. And one of the ways that we make our own lives easier is we introduce new programming languages and new frameworks that can get us to more places and do more things more and more efficiently. And because of that, what you'll see is constant introduction of new technology. So by being forced to learn in these multiple different contexts, so functional programming, in my class, object-oriented programming, in Reid's course, full stack web development, you're being forced to think in all of these different paradigms so that when the world changes again, you will be ready to make that move. So it's never the case that you've learned it. That's the thing. You have to learn how to learn it. And that's really the big thing that you get from this sequence of courses. Okay, so that's, Gregor, anything to add?
Yeah, I'll just add, I like just being able to add at the end thing. I'll just add one thing to the end of that too. This point about how it's always changing really, really is important. We always have conversations with our colleagues in other departments in faculty of science, for example, because in some fields, the intro courses change the most slowly. But in software development, almost the intro courses change the most quickly. And one of the things we've really designed this program to try to do is to push you out to kind of where we see the future in 5 or 8 years. Try to give you some sense of what that's going to be. Because if we, for example, use a 10-year-old book and give you a 15-year-old story, that's not going to be a great foundation for you. So one of the things we've really tried to do across the entire program is reach as far forward as we can reach with great deal of confidence into what the field is going to be like, at least what it's going to be like at the premier organizations in the next 5 or 10 years or so. So I just add that. I think we're back to what's the next one? Next slide, please.
So we can move to the question and answer period. If is that okay for you, Gregor? Yeah,
it is great. While you do that, I'm going to make up and answer the first question. We're now 1/3 of the way through our first offering of this. And so let me assume that somebody asked the question, what have you learned from the first offering of this? And the answer is, we had a great group of learners the first time. And I think we've learned some things about supporting people who are as busy as you all tend to be, and whose schedule is as demanding as your all schedule tends to be. And so in the second offering that we're about to start from the beginning, we're gonna double the office hours that we make available to people. They'll be both Tuesday evening and Saturday and weekend office hours. And we're going to make those office hours be a little bit more classroom-like if people want them to be. And the other thing that we're going to do, and I think this was the big thing we learned, is I think we're kind of used to students who show up on day one and they're ready to go. And what we learned was that a number of adult learners really needed some time to get their everything on their machine completely configured to be set. So we're going to soft open the courses about a week early and really provide support in that time. What we know about configuring your machine to program is it's not the people, it's the machines. But 95% of the machines configure in about 10 minutes and it's just no problem. And 5% of the machines put up a fight. So we're opening a week early this next time, just to try to help with those 5% of the machines that put up a fight. so that it's easier to start for those people. So those are some of the improvements that we're making. And I think, you know, in part because the field is always changing, we're always going to be improving these things and learning from you all as well as our UBC credit students. Are you going to pick the questions or am I, Emily?
Gregor, you can, and then I can move the questions up for you.
All right, well, let's start with that first one because it's a very common question.
Sounds good.
The answer to this question, again, goes back to Elisa's point about how quickly things change. The question is, what are the programming languages taught in the course? And we got a couple things to say about this. One thing is, while that's a common question, and it's an important question, it's one that's out there a lot, one of the goals of this program is for that question to seem less important to you. For the simple reason that very often if you get a software development job, a true software development job, you know, you'll have to learn 1 or 2 or 3 or 5 new languages in your first 2 years there. So we really want you not to be bound to languages. What we're trying to teach you is software development, right? That engineering and design and social practice that produces reliable software in any language and on any technology stack. So in the first course, to really give you a foundation for that, the first 2 courses, we use a special teaching language that is only used for teaching. It's the core of essentially every language you'll ever use, but it's deliberately very small. And we do it for 2 reasons. One is to really focus on the design. And the other is it levels the playing field. No one walks into the room knowing that language already. So everybody in the room is starting from square one and learning software design. And then as Elisa said, we use Java in the second course and TypeScript we use Java in the 3rd and 4th courses and TypeScript in the 5th and 6th courses. Elisa and Reid, do you want to add to that?
No, that sums up for me, but Reid might want to say more about what I see a question in here about what happens in that 3rd course. So Reid, do you want to expand on that a little bit?
Yeah.
Sorry, the third pair, I mean.
Yeah, so the 3rd course really ends up being it's a software engineering course. Obviously, that's the title of the 3rd course. And I guess it's so weird for us because it's in pairs. It's the 5th course, and then the 6th course is a capstone project. So the one advantage that this online format has compared to an in-class format is that in class, we are really rushing to deal with the capstone project mix the capstone project in with the course content. And this ends up being a chicken and the egg kind of problem because learners are busy working on the project and they learn about a topic that would have been useful to know after it had happened because there's just not enough time to front load everything. So what we do in the 5th course is we really spend a lot of time talking about what software engineering looks like in practice on real teams from a specification design and testing and construction point of view. So really just the whole process of building and validating software. And then that last course, the 6th course, is a project-based course. And that is really building quite a challenging project. That is a full stack. So it has a back end, it has a web-based front end, there's a lot of extensive testing, and we've built this infrastructure around it to help guide you through the development of this project, because it does end up being a few thousand lines of code. It's quite large, but there's this automated test suite that helps you to gain feedback and understand how you're doing. So that's what that last class is really all about.
Let me pick up another one of these questions that I see up here, which is the comparison to the program that's offered on edX, the edX MicroMasters. And that's an important question, so I'm glad to have a shot at answering it. I guess the main thing, those courses do share a kind of back-end content. There's a lot of video in those courses that is shared between the extended learning program and the edX MicroMasters program. But but there's a lot more in the extended learning program, which is why it costs more. The students on edX.org are not getting weekly participation. They're not getting a very well answered discussion forum. They're not getting graded assessments other than sort of end of term project assessments. So, a lot of that content is there. I think if you're a really dedicated, really keen, really good self-learner who's adept at this material, I'll be honest, you could go through the edX material and learn quite a lot. For people who maybe need a bit more support, are more busy, haven't been in school for a while, I think the kind of support that we're going to be providing you in the extended learning program is going to make it a more rewarding experience for you. But that really is the difference between the two programs. One is very much of on your own self-study. The other one is online, and it's asynchronously online. You won't have to participate in lectures at a certain time. But there will be a community of people that's going through it with you at the same pace. There will be weekly office hours. There will be course staff answering the discussion forum. There'll be a lot more support than you would be getting in the edX context. Which one should we do next?
Yeah, I just wanted to quickly add, like, that is definitely true. That the support is definitely a huge thing. So like the type of forum activity that we're going to be having for these courses is really different. We have sort of a dedicated person who's just answering questions, and that is a lot. Like the edX is much more of a community. Like students answer each other's questions far more, whereas in this offering we have somebody who's dedicated to answering forum questions, and that's a really big value add. Like you're getting, I only know the staffing for my own pair of courses, but the person who's assigned for my courses anyway, is like our award-winning most excellent TA from the department, and
ours is more award-winning and more excellent.
No, nobody's better than nobody's better than Noah, and it's just like it's a privilege to work with them. So I think that's a selling point in itself.
I was just kidding. I was kidding about that. Noah's fantastic, but similarly, in the first course, we have someone who has TA'd the UBC version of the course 11 times. Except that you're not allowed to let students lecture, we might let this person lecture. We really are putting extraordinarily good staff there to support your learning in these classes. Several people have asked about specific days and times. I think we've said that, but let me say it again. These courses will be what we call asynchronous online. So the lecture components are all recorded. You can watch them at any time. The weekly office hours will be scheduled. In each course, they'll be scheduled for a certain time. So that'll be the only piece that's really scheduled. There is a schedule to the course, though. There are weekly assignments that are due. Part of what's the support in this class is the notion that 60 or 70 of you are going to kind of do this thing together. So there is a schedule to it, but you don't have to attend lecture at certain times.
And I'll just add to that, Gregor. So the office hours, people may be curious when they would be. They're typically scheduled on a weekday evening and on a weekend. So we will publish the office hours for the first two courses within the next 2 weeks. So stay tuned for that information to come. Gregor, did you want to answer the question about the recording?
I think it was in my previous thing, but let me just make it really clear because that's so important. All of the lecture content will be recorded, and you can watch it at any time. There'll be no live lecture content. The schedule that adult learners have is so complicated that we could never pick a lecture time. And then there'll be twice weekly office hours. Those will be the only things that will be at a set time.
There's a question about the syllabus for the courses. So you can email our student services team from the website and we can provide that to you.
Reid or Elisa, do you want to tackle this? So we have no students who have completed this program because it just started in November. But we can talk about what co-op students at UBC who have completed the equivalent of this program, what they're able to do. Reid or Elisa, do you want to tackle that?
Yeah, I mean,
Oh, sorry. Yep.
Yeah, sure. I'll go first. I think the way we look at it at the end of the final course of this sequence, the UBC equivalent to the final course of this sequence, we think our students can be successful in any technical co-op job. And that's great, right? So we've had students go to Twitter, and we've had students at Google and Microsoft, we've had students downtown at Visier and Salesforce, and they're able to be successful on those teams. And really, like, the project that is at the end of the last course of the sequence is the largest development project we have in our undergrad program. So it really gets you to that point where you can be a successful contributor on a real technical team. And that's where we really want, we really aim for you to be able to get to by the end of this sequence. Elisa?
Yeah, I mean, even after the second pair of courses in our program, students do go out onto co-op jobs. And so they wouldn't have, like, by the end of the third pair, students will have had a very rich experience going through lots of courses. So it's not necessarily exactly the same, but after the second pair of courses, students also go out and their experience will be much more similar to the experience you will have at that point. And then you will have a little bit, not a little bit, but a significant amount more experience after having done the third pair of courses. And the types of jobs that they get are they're very entry level. I mean, they're entry level work, but they are substantive. They involve development. They're not just helper positions. They're not just doing QA, which is, quality assurance or testing. They are often doing entry-level types of things like fixing bugs in systems, or maybe adding new, smaller features to systems, and things like that. So there's a tremendous richness to the kinds of work that you can do, even after the second course in the sequence, and then especially after the third, where you have a much deeper breadth of understanding of the architecture of systems and the way that systems start to fit together. So that's really the zooming out that we do in this sequence. So in the first course in the sequence, you understand how to design programs that are kind of self-contained and exist within themselves. In the second course, you learn how to develop kind of almost multi-component systems. And in the third course, you're developing systems that operate almost on different machines, like a client service kind of feeling. That's true, is it, Reid? Like, I'm speaking on your behalf, but and so by the end, you have a pretty good understanding of how different kinds of systems fit together, and a sort of more wisdom and breadth of perception there. So you're much more prepared to do different kinds of jobs. So yeah, but I also want to not limit the amount of pressure that's placed on doing your own work at the same time. So these courses, they give you the basis for doing something, but if you are serious about wanting to go out and get a software development, getting a software development job, you do have to do your own portfolio work. That's true for our CPSC major undergrads as well. They have to do their own portfolio work. You have to practice, just like with playing an instrument or like with tennis or whatever. You have to actually do it, and then jobs are really interested in seeing what you've done. So you can boost up your portfolio by investing additional time in gaining that experience. So yeah, it's not just that by the time you've finished all of your hours in the course, you are hireable by the world. You also have to put in the work of doing your own projects. Gregor and Reid, would you agree with that?
I mean, I think that's exactly right. And let me just say something that I think was key to what Elisa said, but was a bit implicit. Look, there's a range of jobs out there. Okay, there's a range of jobs out there. You will not, after just these 6 courses, be in line for a super key role in the kernel part of Amazon Web Services. Okay, now that's going to take a little bit of time to get there, but you will be, as Elisa said, ready to take on real software development work in a real organization, working in a real professional way. But you'll be part of a team, and you'll be doing kind of work that teams do, the kind of work that teams give people who are being onboarded to get them familiar with the situation. So you'll be able to contribute, you'll be of value. But as Elisa said, this is a field in which you'll be learning every day for the rest of your career. So the learning won't be done, but you will be ready to get your foot in the door and start contributing. I had no previous. I think so. This first question that's on the screen now, I do feel like we have answered that. When this is done, you'll be able to independently develop software using the kinds of technology that we'll have used in this course. If you want to develop software that uses a different programming language or a different framework or a different operating system or something like that, you'll have to do some more learning, but you'll be ready to do that learning.
Sorry. Practice, right?
Practice. It is. The joke that I tell my students is, what will happen to you is, you will get your first co-op and they'll tell you, you're going to be doing this, in Ruby. And, you spend the whole month of April learning Ruby because you want to be ready. And you show up for work and you say, I'm all ready to do this thing using this framework in Ruby. And they say, oh, Ruby is so April. You're actually going to be doing this in this language. And then you kind of got to go home that night and learn that. That's just part of it. We're always learning.
Yeah.
Can someone not having an academic degree in computer science follow in this course? Yes, absolutely. This course is intended for people who have no computer science background whatsoever. And I think we've answered the question about is it possible to find a job with only this training?
Yeah, and yes, definitely. You don't have to register as a professional engineer. You could call yourself a software engineer. I think.
Lisa.
Is that true? No? You can say so. No? Okay, go ahead.
You're breaking up.
Oh,
okay.
it's my.
Let me just answer this question.
Okay, thanks.
You will be able to apply for and hold jobs called software engineers, called software engineering positions. And I know this sounds like we're being lawyerly, but this is just a continually evolving space, particularly in Canada, with the designation of being an engineer. So most professional software engineers in Canada do not have a PEng. And this program is not a PEng program. So that's really the answer.
Yeah, and the key thing to highlight in that sentence is most companies, when they advertise software engineering position, don't have PEng in mind. That's why I was kidding Elisa. Because we have colleagues at the university who are PEng, we have to be careful to say this properly. Do one of you two want to grab one of these 4?
Yeah, so I'll say something. It's funny. It says the bottom one keeps changing because it's the latest question, but I'll answer 2 of the recent bottom ones that have come up. So this one is about specific skills for e-commerce technology development, and a prior question was about building interactive web-based databases. The capstone project is you're actually implementing a database yourself that handles queries from a front end over the web. So you are essentially building the back end that could be used as a database, or you have the same end-to-end information flow as happens in all e-commerce systems. So it's totally applicable to that. If you were to look online for the kinds of job postings that the project is really based around, they'd be called full stack web development jobs. And that's really where we're at with those. Does someone want to talk about one of the others?
I'll do co-op, but I'll just do it quickly. This program doesn't offer co-op opportunity. But let me just say one thing about that. You all are going to take into, once you have this program under your belt and you're looking for work, you'll have a disadvantage, which is you didn't have the co-op program available to you. But you'll have an advantage, which is that you have a lot of the outcomes of the co-op program available to you. You've already held real jobs. You've already, worked in real organizations. You've already got a ton of the kind of stuff that people learn in co-op. And as Reid alluded to at the beginning, a lot of people who start to learn software development don't change companies. They just change roles within that company, or don't change organizations. They just change roles within that organization. So yes, the official UBC co-op program is not open to you, but you have some huge advantages that our undergrads, in fact, don't have when they finish. You've got all this experience.
So somebody in the lower regions of the questions were asking, like, what is a co-op? We keep using this co-op. Co-op, it's basically a job posting while you're doing your degree. We have sort of an internal job finding service within the department, and students can apply for jobs that are appropriate for somebody who is currently doing their education. And there's kind of a matching process. So that's what we can, and then the jobs are usually only 4 months long or 8 months long. And so those are called co-op terms, cooperative education terms. So I hope that answers your question. How much focus will be on algorithms and programming logic skills? That's the top question at the moment. I would say the first pair of courses probably looks most at algorithms themselves and logic skills, but in terms of optimizations and things like that, I think those are not necessarily the focus of the course. That's the kind of thing that you can get in a more broad computer science degree, is a lot of thinking about efficiency of different kinds of algorithms. However, in the first course, I believe that you do focus on efficient ways of recursing trees and looking at manipulating data structures. And I know in the second pair of courses, in my pair, we look at efficient data structures for different kinds of scenarios. So making choices that will lead to programs that are both quick in terms of how fast they run on a machine, but also in terms of the efficiency of how you're going to be working with them. So whenever you're thinking about software development, you can't just think like, how fast will this run on a machine? That's kind of an outdated way of thinking about software. Instead, you also want to be thinking, how able am I going to be to change this program, and how effectively will I be able to interact with, will I be able to code my code base in the future to be able to get out the information that I need? So we think about it in terms of those kinds of things. I hope that answers your question.
Yeah, this connects to a point that Reid made earlier about how important it is, how team-oriented a thing it is. One of the things we drill over and over in the first course is your number one job is to make the program easy for the next person to read. That's your number one job. We can worry about making it fast later if it is slow. And that really takes, for people who programmed maybe 20 years ago and who are coming back, as Elisa said, this really is a new idea that performance optimization until the program runs is better delayed, because then you really know something. Whereas making the program easy for the next person to read is something you need to do from day one.
Oh, these are good questions.
Yeah, these are good. You do one.
Okay, so to an employer, what's the value of a program like this compared to a 4-year computer science degree? I think that's a really, really good question. Like, why would an employer prefer this? I think it's perhaps because of the people who would be doing this versus doing the full 4-year computer science degree. So full computer science degree is 4 years long. It's expensive and it takes a long time. It maybe even takes longer than 4 years. We say it's 4 years, but sometimes it's 5. And it's often for people who are coming straight out of high school, right? Like they go into their undergrad and they kind of do that. And this kind of educational opportunity is more for folks who have had a breadth of experience in life, and then are adding to that breadth of experience with a new set of skills, a new technological perspective, and they're bringing the wisdom from their entire past history to that education. So they have a lot of knowledge about trade-offs in life, trade-offs in industry, figuring out what it means to make a pragmatic choice. Like, I can't necessarily afford this, so I'm going to do that. These are the kinds of things, this kind of life experience you wouldn't think has a tremendous impact on your effectiveness as a software developer, but it really, really does. It's one of the principles of software development right now that has sort of endured for a few years now is pragmatism, being able to make pragmatic choices about your software design. And it's very difficult for someone who's very young, who hasn't lived a lot of life, to be able to make these kinds of pragmatic decisions. Like, I'm going to put that off and I'm going to make this decision for today. Or I can see that something that I'm doing right now is going to build up some sort of debt that I'm going to have to pay down later. And it's these, that is kind of why an employer might think, I want somebody with both, like, a food services background or a biology background or a sales background, who then has also now incorporated this technological understanding. That might be far more valuable to them than someone who has a lot of this kind of undergraduate, kind of capsule of knowledge. So that would be my answer to that. So what are your thoughts on Dogecoin? I guess I think you should have bought, a year ago, is always my thought about all of these cryptocurrencies. Like, shucks, I should have bought a year ago. And maybe except for Bitcoin, I think buying a year ago might have been bad. But those are my only thoughts about that. Definitely GameStop, I wish I'd bought a year ago.
Emily, do you want to maybe just grab it back for just 1 second and do a quick overview of the timing and the costs and everything like that? Because there's a couple questions.
Yeah, I can cover the cost, because there's one more slide at the end that will cover that. So I'll let you address the other questions first, and I'll do that at the very end.
There's a really good question about this program versus boot camps, and also another one about, as a 40-plus-year-old, could I do this and change my career? I really like, and then I'm already 28, so there are different age ranges here. But I think, the difference between this.
Let me try the boot camp one. Is that okay?
The boot camp one, yeah, good. And I'll comment on age. I think we'd all like to know.
So I think I would say the following thing about the boot camps. I don't want to be too negative, but I will tell you a few things about the boot camps. One of the reasons the boot camps turn out people who are capable is the boot camps only accept people who are capable. So, that's a factor. Another thing I would say about the boot camps is, I think, and it starts with the name, that they're needlessly macho. I'm not sure there is any needed macho, but they're certainly needlessly macho, in a way that I think is really harmful to not just the prospective students, but to the industry as a whole, because I think it puts out that message that that's what it is. I'll just repeat the thing that Reid said. software development is first and foremost about playing nice with others. It's first and foremost a joint social activity. Software is a socially constructed artifact. You know, I don't know. Somebody who brings a lot of macho-ness to that isn't, I think, going to necessarily add the most value. So I'm a bit, skeptical about the boot camps. On the other hand, there are some people for whom they work quite well. I also think they tend to be very focused on the current technology. And while that's good, I think we've made it clear that if all you know is the current technology, then there's a timer running over your head, and it's not a very long timer. You really need to know what underlies that technology so that when there's new technology every 6 months, your emotional response to that is, oh yeah, I got to take this weekend and learn this new thing. It isn't, oh, I don't know new things. So, yeah, the answer, not surprisingly, my answer is going to be, I think this program is a better long-term investment than the boot camps for most people.
I would agree. I mean, I think also it depends what kind of job you're wanting to get. So I think the boot camps that I've heard of, and I'm not an expert, as Gregor said, they focus on kind of skills, but they're also skills that don't necessarily require a depth of understanding about computer science thinking. They require a kind of it's not that they're just teaching Excel by any means, that's definitely not what I'm saying, but it's kind of a couple of levels deeper than that. But it's basically manipulating technology as opposed to thinking like a developer, like thinking in terms of design, longevity of systems, robustness, ability to plan for multi-person projects. It's a different kind of education. And that's not to say that these can't be stacked on top of each other. So maybe you could gain a proficiency with the technology and then think, oh, I'd love to go more deeply into that and get more responsibility in the software industry and have kind of a deeper experience there. And then you would really be craving something more like this program. So I think that there is a difference in terms of levels of depth that you get with those. So one is more about like kind of skills and a quick proficiency with current skills versus thinking in the mindset of a long-term software developer.
Thank you so much. I know we're really there's so many great questions here. So I'm just gonna go over the next steps. So the next intake is gonna be from April 27th to April 18th next year. So it's a year-long program. The cost is close to $6,000 if you register a month before the course start date. So register by March 30th and you'll save $420. There's more information about the program on our website. Please take a look. And at the end, I would do a quick poll. Just curious, when do you hope to participate in this program? April 27th is our most immediate intake. And if not, there is also another intake in the fall starting in October. Thank you so much, everyone, for joining us today. Again, the recording for this session will be posted on our YouTube channel, and we'll send that to you by email. And if you have any other questions, we're happy to address them by email. Thanks again for joining us.
Thanks for spending your time with us, everybody.
Thank you.